This example is an application of our vector formula that we've been using all throughout this lesson in terms of the flight of an airplane. So we've got an airplane that says here it's flying on a bearing of 170 at 460 miles per hour. We want to find the component form of the velocity of the airplane, so the vector for the velocity. Now, a couple of things that we need, as usual for this formula, we need magnitude and we need a direction angle. Magnitude's pretty straightforward. That is just going to be the speed of the airplane. And the direction angle is somehow related to this 170, but remember that when we're talking bearing, it's a little bit different. We need a trig angle for the direction of this vector. So we got to think about how to convert bearing to a regular trig angle. So I'm going to draw a picture of that. Remember that with bearing, it's measured clockwise from due north. So you start due north and you go clockwise, and we're going 170 degrees. So the bearing looks like this, where it's 170 degrees this way. Okay, so that's what they're talking about as far as the path of this airplane. Well, we need to convert that to a trig angle instead. So with a trig angle, if we're going back this direction, we could do all the way around, but it'd probably be easier just to do a negative angle. And that negative angle is going to be related to this 170, and that if we've already gone 90 degrees, we take that out of the 170 and we go another 80. But this one is negative because it's a regular trig angle, so that means that our angle is going to be negative 80 degrees. Now we can use that negative 80 degrees and plug it into our formula. So like I said, the magnitude is 460, and then we can multiply that by cosine of the angle, sine of the angle. This will give us a vector for the velocity of the airplane. It's basically the direction and the amount that it's going in that direction. And so we do cosine and sine, distribute the 460 just to eliminate some of the details here. That'll simplify down into about 79.88 negative 453.01, and we're going to talk a little more about that in the next example as far as what that means for us with the path of this airplane.